Hello, my name is Rich Howard, owner of Architectural Builder Supply, and this video is to bring you a closer look at the Von Duprin part number 050242. It's basically a annunciator, or what they call an entry buzzer. It's nothing other than a piece of hardware that makes a sound, an audible sound, when the circuit is closed, meaning when you want to hear something, based on the circuit being powered with electricity, this entry buzzer will allow it to announce that something is happening. So in this case, if you have an electric strike and you want to hear when it's unlocked, you would use an 050242 entry buzzer. But let's talk more specifically about what it's used before we do that, or how it's used. Let's take some basic dimensional properties. By the way, it weighs 0.06 pounds, so there's not much to this. Overall length, including the mounting ears, looks like it's about 2 3/8. Diameter of the body, about an inch and 5/8. Thickness, looks like it's about 5/8. Obviously, you're going to have one connection to the strike, one connection to your power, is how this is going to work. Actually, it's shown in the instructions, which we'll go over in a moment. So let's talk more specifically about where and when you might use this entry buzzer. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. So Von Duprin calls this an entry buzzer. Other manufacturers call theirs annunciators. It doesn't really matter what it's being called, in the sense that here's where you're going to use this. There's AC voltage and DC voltage. When you have an AC powered electric strike and you open the strike, meaning you send electricity to it to unlock, it will make a sound. It will make a buzzing sound. And if you've ever heard the term, which you certainly have, buzz someone in, that literally means they're going to use an electric strike to release the lock to allow the door to open. That's most definitely an AC circuit. We know that because only AC buzzes when the circuit is closed, meaning when the circuit is closed versus when the circuit is open. When the circuit is closed, there's power flowing. When the circuit is open, there's no power flowing, meaning the switch hasn't been thrown or the button hasn't been pushed. So when you have an AC strike, there'll be a typical AC strike is a small jewelry store. And the people inside, the employees inside, can see you outside at the front door, and they will then buzz you in. Somebody will literally touch a push button, just like a doorbell button, is the bottom line. That closes the circuit momentarily. As long as they're holding that button, power flows, it buzzes, they see you pull the door open and come in, and they let their hand off the button, the circuit opens, the buzzing stops. Great, that's AC. Well, what if you have a DC strike? Well, if you have a DC strike, all of that will still work, except that when you close the circuit, you don't hear a buzz. All you'll really hear is a clicking sound if there's a solenoid. So you don't actually hear anything. If you've ever walked up to a door and you've presented a badge, or entered a pin on a magnetic lock or an electric strike, you won't hear a buzzing. You might see a light change from red to green or whatever it might be. You may hear the click to know that you pull the door open. However, you might want to add the ability to add a buzzing sound to a DC circuit. So the bottom line is, you'll have a DC circuit and you want to add the enunciating or the buzzing sound. That's what you use this for. That's specifically where you'll use this. You can use this Von Duprin entry buzzer on anyone's hardware. It's just a low voltage gizmo that makes a lot of noise. What's nice about using it with Von Duprin strikes is it will plug right into their system. It's got quick connectors on it. Okay, if I were to cut those connectors off and simply wire my negative and positive wires to my DC low voltage circuit, not a problem at all. And in fact, I'll prove that. I'll just put the power supply behind me and 2 powered leads directly onto any of the contacts here in the connectors so that you can hear it. In fact, let's do that right now, and then we'll move on and look at the supporting information we have. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Alright, what I have here is a typical power supply. Okay, it's powered, it's turned on, it's producing 24 volts. Typical Locksmith 510. It's a discontinued power supply nowadays. It doesn't really matter that it's discontinued. So we have our entry buzzer, and basically it's powered, and I've got 2 leads going here. And just to demonstrate the sound, I'm simply going to touch these wires inside of here so you can hear it actually work. So that's insanely loud, in my opinion. That is far too loud. I don't know how many decibels this is. Terry, you can cover your ears if you want. I don't know how many decibels that is, but in my opinion, that is far too loud for an electric strike. But the argument for it being louder is the fact that it'll be buried inside of a frame, you know, a wall. It's going to be not out in the open. So that would explain why it's so loud. I personally wouldn't want that sort of decibel level produced all the time. But the reason it's that loud is because of where it's being used. All right, let's switch to the screen view and let's take a closer look at all of the supporting information. All right, here's some images of what we're dealing with here. Not terribly much to see, but male connector, female connector, the back side of the entry buzzer. That's the deal right there. Instructions. Okay, so one's going to your power, the other's going to your strike. It can't, I suppose it can't really be any easier than this. So when the circuit is closed, closed is just a fancy way for saying when there's power running through when there's juice, you know, when there's electricity racing through the wires, which are called the conductors. You know, it's going to power this circuit. AC voltage has to go back and forth. DC voltage has to as well, except a DC voltage goes on a path in a big circle like train tracks. Whereas with AC voltage, it will go down one track and back the other track, and back that. Actually, it goes down just one track, back and forth, back and forth, back and forth. So anyway, it's powered, and when the circuit is closed or the button is pushed momentarily, whatever it might be, not only does the strike get power, but at the same time, so does the entry buzzer. So when the circuit is closed, you're powering both of the units that are plugged into the power, in fact, so the strike and the buzzer. All right, let's wrap up this video on camera. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Okay, this is a reasonably obscure item, but nonetheless the need to give DC circuits the ability to have some audible energy given off as well does exist. I don't sell enunciators very often, but when you do, you know, it's a necessary component of that circuit. Your client might say, yeah, I want to be able to buzz people in, and then you have to talk, you know, what strike are we using? Fail safe or fail secure? AC, what's your power coming in, AC or DC voltage? So this type of strike also requires the explanation of FSE only is in the title or the product ID of this as well. It's probably on the instructions, I would guess. Fail secure only. So there are 2 states of electrical hardware, electrified hardware. Fail safe and fail secure. How it's defined is when the power is cut. When the power is cut in a fail secure, the lock stays locked. Whatever it is. The electric strike, the panic device, the lock set, an electromagnetic lock, which there would never be a fail secure electromagnetic lock. When you have fail safe, when the power is cut, it's unlocked. So you have you have to think about what we call your operational description. What do you want to happen when there's no power? Are you locked or are you unlocked? 4 things to think about. What is the standard operating condition of the door? What is it when you just walk up to it? What is it already? What happens when the power goes out? Well, basically, what's the normal condition of the door? How do you get in? How do you get out? And what happens on upon loss of power? So you have to answer those 4 questions, or define those 4 variables. But because this is FSE only, we need to think about that. Fail secure only. Why would this be fail secure only? If it was fail safe, if we wired this into a fail safe circuit, it may not meet our 4 requirements, because part of your description is what's the normal state of the opening, what happens to get out, what happens to get in, and what happens when the power goes out. Well, how to get out and how to get in, you're probably going to mention in your description, upon activating the electric strike via the push button, the lock will be unlocked, or the strike will be unlocked, allowing ingress, and the entry buzzer will enunciate. So you would indicate that. You'd say those words or something like that. The only time this will enunciate is when it's getting power. If you want the lock to be locked when there's no power, the entry buzzer wouldn't be buzzing. But now think about a fail-safe strike. The purpose is that door to be locked. In a fail-safe environment, you would have to power that continuously to lock it, because upon loss of power in fail-safe, it's unlocked. In a fail-secure, the only way to enter is to power it temporarily. Otherwise, when there's no power, it's locked. If you had this installed in a fail-secure environment, you won't hear this until you buzz someone in. But if you had this installed in a fail-safe environment, it would be continuously buzzing. And the only time it would stop is when you push the button to buzz someone in, except in this instance, it would turn off. So that's why this is fail-safe only. This is fail-secure only, and would be used in those applications. If you have any questions on the 050242 entry buzzer or any other Von Duprin product, please feel free to reach out to us. And thank you. Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.